Hi, I'm Ernie Conover. Welcome to my shop. Turning tools have been around for hundreds of years. Moxon's book of approximately 1700, it was written really a few years before and after, pretty much depicts all of the turning tools that turners generally use, what you would call traditional or conventional tools. But around 2005, give or take a year or two, a new type of tool burst on the marketplace, and it came from machine tools. And it uses a handle in which there's a shaft that ends in a pocket in which you put a carbide insert of various shapes. Generally, most manufacturers have 3 shapes. This array here is from Easy Wood Tools, an early entry into the marketplace for this type of tool. And we have the first one has a round insert, and then the second one has a square insert, and the third one has a diamond insert. Some end in a very sharp point, others end in a radius, as this one does. And all of these allow you to pretty much turn any shape you want to turn. The square ones often come as well with a radius on the edges, and there's usually a couple of different radiuses offered. Another attractive thing is that you need $400 or $500 worth of grinding equipment and jigs to sharpen these conventional tools, and you don't need any sharpening equipment at all. You just throw this cutter away and put a new one in, and they're fairly inexpensive. To turn bowls, you would also need 2 sizes of bowl gouge, and you would also need these scrapers for bowls, larger ones. So there has to be a catch, you say. Well, there is. A properly sharpened conventional tool in skilled hands will generally give a better finish and do the job faster than carbide insert tooling. However, a lot of practice is necessary to get to the point where you can use all of these tools with great competence. However, there's the grandfather that would like to make a cradle for a new granddaughter with the lathe that's been gathering dust for ages, and he doesn't have a bench grinder. There's the furniture maker that just wants to make 4 legs for a table and do some turning now and then, but really doesn't want to be a turner. He wants to be a furniture maker. There's the young person that you would like to introduce to turning. All of these are great candidates for insert tools. I'd like to now take this nice, slightly curly maple billet and put it between centers, and we're going to turn a Windsor chair stretcher, which is mirror imaged side to side. It'll be bulged in the middle and go out to a mushroom-shaped bobbin on each end and a tenon. And we'll turn half with conventional tools and half with the insert tools, and we'll be able to see what each finish looks like off the tools. So this is a shootout, really. All right, it's taken me 10 minutes and 33 seconds to turn this half of this chair stretcher. So we'll now turn this around. This is often a good trick when you're turning symmetrical parts, is simply point this the other way, and we'll now turn this half of it. We'll start out using our round insert tool. Now, with insert tools, you generally want to work with a little lower rest than you would in conventional spindle tools. so that we have this cutter pretty much on what's the center line of the lathe. That's an imaginary plane that runs between the centers. And we're going to hold the tool pretty level on the rest. You can see now that we're round, that this tool is actually doing a pretty good job. All right, now we'll use our square insert tool and a 5/8 wrench to bring it down to our 5/8 inch tenon right here. There we go, that's a 5/8 tenon. We'll put a little chamfer on that corner so it starts nice. We want it to be about 5/8 long. So we'll now bring this down to that diameter. Now we'll start to make the half bead right here with the edge of our insert tool. And we'll go back to our round tool to make a half cove right here. And I'll fair out this curve a little bit. These do very nice by dragging them, you know, just as good a shape here as I have there. Now I need to remove a bunch of material from down here. Sense of feel will tell you what a lot. I've got a rough spot right in there. Now we could use our diamond tool to, one, put this center accent line in a little better, like that. And if we go in here at the head of our bobbin and just below, it will put a little bit of accent on that, make it pop out to your eye a little better. And there. Our finish is definitely better here than it is here, but this is nothing that wouldn't sand out pretty fast. And it's taken us 13 minutes and 23 seconds to do this half. So the time is a little slower, but isn't vastly different. All right, I've now mounted a nice sassafras bowl on the lathe. It was roughed out months ago. And we'll now true it up and get a nice bowl for our effort. I have the lathe running at about 800 RPMs, and I'm going to come in here and very lightly touch here. I'm reading the ghost, which is, this isn't really round yet. I have this absolutely flat on the rest. There is an extension limit here you should obey, not get out beyond that extension limit. Okay, well now, true up the outside of this tool. On the outside, it's best if you go from the base to the rim. And on the inside, it's best if you go from the rim to the base. And there we have our finished bowl. Some sanding, and this is faceplate work, so I always joke that it's not if you sand, it's how much you have to sand. And with these insert tools, you'll have to sand a bit more than you would with a really sharp gouge used correctly. Again, the caveat is skilled hands, sharpened correctly, used correctly. These, as you can see, are very intuitive. You just watch the shape happen, and you can very quickly make the shapes you want. There are some places where I personally use carbide insert tools in preference to conventional tools. One place is deep hollowing like this, what are called hollow forms. And these are really spindle turned vessels, but you turn them through a small mouth opening and very deep with thin walls. And this very heavy, and I should add that insert tools come in sizes, and this one is designed for this. This is like another easy wood tool. Small cutter is better than a big one for this kind of work because you can't lose control of it. And you can see they've put a very thick section on here. Strength of a beam is a power of 3 in height. So that extra height makes this a lot more rigid out there. And I can go right down here to the bottom of this and work my way right up the wall. I might add that many manufacturers make these, including Easy Tool, that have a crook in the end of it that comes out this way, so you can get down inside of here and you can get around this rim area and get back in here better. So take a look at the marketplace out there. There's a lot of cool carbide insert tools that are great for hollow forms. Another place that carbide insert tooling works very well is in turning plastic resins. This is an acrylic plastic resin right here, and I've turned it from square to round with this plain old spindle gouge. And if you can see, there's all kinds of little chips that are happening in a repeating pattern here. Now, Easy Wood Tools actually has a scraper that has negative rake on it. It's sloped downward around the outside edge. So when we bring this down so that we're cutting on the center line, we're actually leaning the tool downhill. Every material has an angle at which it likes to be cut, an optimum chip raising angle. For wood and most metals such as steel, a positive cut where the top of the tool is slanted into the cut will raise a chip and give you the best finish. But other materials like brass or copper actually want a negative 5 degrees of rake, that the tool is leaning away from the cut. And that's what this insert for their tools will accomplish. I always like to wear a mask when I'm doing these kinds of plastics because they chip so easily. But and you can see that I now have a surface that's free of all these little chip marks. And this tool is doing much better because it has the right angle of attack. So again, this is a place where the insert tools can do a better job.